Before I dive into using GitHub Copilot, one of the things that I also want to emphasize, so I'm using VS Code as my example IDE for today. You can find within the VS Code marketplace for extensions, we're listed, SonarLint, you'll find us right here. And once SonarLint is installed in the IDE, you'll also find SonarLint available in the sidebar on your IDE in other flavors of IDEs. So for example, like JetBrains, IntelliJ, VS Code, Visual Studio, Eclipse, those are the major families that we support. You'll find variations on each IDE has a marketplace. And of course, each IDE has usability conventions as far as how exactly our tools show up. But so one of the things that I want to highlight is, of course, the interaction that we'll see between GitHub Copilot and the IDE, as well as the interplay with SonarLint. So I have just the beginning framework of a project that's intended to have some JavaScript code added to it here. There's really nothing that exists yet. So really what this represents is a state where I'm about to add some code. And let's say that one of the things that I want to implement within this project is going to be some kind of web API. So I'd like to use a RESTful web API, and I'm going to pick a subject. Let's say dogs. I love dogs. So let's ask GitHub Copilot to, for example, generate a RESTful API in JavaScript for dogs. And let's say each dog should have a name, a breed, and a date of birth. Great. So GitHub Copilot will go along and think about that. And it's going to give us a nice implementation. We'll see how nice it is. This is looking pretty promising. So it looks like it's decided to use the Express JavaScript framework. There's some other things going on here. I can see some pretty standard RESTful API operations. And it's even going to helpfully explain to us what exactly it is that it generated. This is all great. So if we want to go ahead and try to make use of this code, we can just go ahead and insert this into a new file. And what we'll see here is I'll go ahead and save this, for example, into a file like dogs.js. And so as soon as the file is added into the IDE, now we're going to see some code. And so as an example here, when SonarLint interacts with code within an IDE, what's happening here is there's not necessarily a direct integration between SonarLint and GitHub Copilot. And in fact, there doesn't need to be. We'll certainly explore in the future whether there are direct integrations that we can put in place that would make what I'm about to show even easier. But even without a direct integration, the really cool thing about these tools is that they're very complementary to each other in the sense that SonarLint is going to analyze the contents of the file. Copilot or even ChatGPT or something that you may copy and paste into the IDE is going to add contents into your code buffer. And even without a direct integration, you have the advantage of these tools working complementary together within the IDE and giving you some feedback. So when you interact with code within the IDE, the problems that would be found by SonarLint or other static analysis linters that you may have added in your IDE are going to show up down in the problems pane. We don't happen to have any problems because the code, honestly, that's generated by Copilot, when you're specific about what you're looking for, it actually happens to be pretty clean for the most part. So we've got a nice implementation of a RESTful API here. This is great. We do see on the side, SonarLint is actually giving us a notification though. So even though there's not any immediate problems, we do also have this other notion within SonarLint that we refer to as a security hotspot. And so a security hotspot was raised on this particular code over the fact that the generated code is using the Express framework in JavaScript. That in and of itself is not necessarily, that's not a bad thing. Express is a super popular framework. However, we're just openly, as written, this code would just openly disclose what the framework is that's being used. And so SonarLint will, when it raises a hotspot or an actual problem finding in the code, walk you through an understanding of a risk like this, and also give you feedback on what would you do if you wanted to make a modification to the code in order to address it. So like in this particular example, we can take the gist of the suggested compliance solution here and go ahead where we're making use of this framework and go ahead and address that. And so we can see now the security hotspot has gone away, and this is fantastic. So we might also want to continue as a developer working with this. Maybe one of the things that I wanted to add to this implementation of my RESTful API is something like we've gone ahead and given the dogs a date of birth. Maybe we should go ahead and also add some affordance in here to be able to do something like generate the age of a dog. So what we can do when we're interacting with the code, you can ask Copilot to go ahead and generate something. So let's say generate a function to calculate the age of a dog. Let's ask it to go ahead and do that. And what this will actually do, which is pretty cool, is go ahead and generate something. And it's actually gone ahead and added it as an inline method. If we in addition to this, let's say we wanted to do something like take this code out and consider externalizing it into another function. We could do something like function calculate age, it takes a date of birth, and in this particular case, maybe we want to start adding some of the code in here. And so you can see SonarLint, as we start to work with the code that Copilot is giving us some feedback in here. One of the things that we see here is it's actually suggesting that we rename the function. And you might wonder, well, why? Why would it be asking us to do that? Especially it's asking us to rewrite it in terms of a particular regular expression. This is actually an example of enforcing a naming convention on the code, which we saw in response to the poll earlier. A lot of you have an almost equal amount of concern between code security and the maintainability and the standards compliance of the code that's being generated. So this is an example here. It might be an almost silly naming convention, but this is an example of the type of convention that you can enforce with Sonar. And how did the IDE know about this if this is a coding convention that's specific to you? It's through the magic of what we refer to as connected mode. So within SonarLint, you can set up a connection between the Sonar process, SonarLint running within the IDE that's giving you live feedback on the code that you're composing, and in fact, your upstream Sonar server. So whether this is a Sonar Cloud subscription, or you've got a SonarQube on-prem or self-managed server that you're using for your teams, you can use that to manage your coding standards. So if you have within your organization defines what we refer to as a quality profile, and maybe you've gone ahead and added on top of what we already have in place as far as the Sonar Way quality profile, you can go ahead and add to your quality profile rules to enforce some of these conventions. So whether it's naming conventions for functions, methods, even trivial things like brace placement, naming for variables, other standards. You'll find within all of our supported languages, if you look for rules that have the tag convention, there are lots of things like this that you can enable. And hopefully for those of you who are already Sonar users, you've gone ahead and enabled those things. Now, when it comes to enforcing a rule like this, what we can actually see is when we look at the code, the IDE's option to generate a quick fix will give us some options here. In many cases, SonarLint has a built-in quick fix. The really cool thing, again, about the interplay through the IDE of these tools is you can even ask Copilot to fix this. And because the description of Sonar's rule is accurate enough, you can in fact have it implement the suggestion of the naming convention for you. So there's a really nice interplay that we see between these tools. I'd like to move on to another example quickly. So, above and beyond this, you might also wonder what would happen if we had some maybe more serious issues that might come along. So a variation on, I was rather specific when we asked for this implementation of a RESTful API. In a previous iteration, I was wondering what would happen if a developer who really kind of didn't know what they were asking for asked Copilot for some questions. And an example here is if I asked it simply to generate some abstract code for a RESTful API, what in fact happened in this particular case is it generated very similar code to my REST API for dogs. But this code was actually so generic that it was doing things like, for lack of any kind of specific object model that we might want to be talking about, like a dog, a person, a customer, it was simply reflecting the body of the request back in the response, which might be a helpful thing to do as you're getting started. If a naive developer actually used a code example like this and tried to extend it into something specific, they could actually wind up getting into a bit of trouble because, in fact, this is a very basic example of a cross-site scripting error. So a cross-site scripting vulnerability, if left in the code, would actually be able to let a potential attacker access the web interface for what this API would result in, and redirect requests to the API to maybe another endpoint where they could then potentially do something malicious. So there's definitely something to watch out for. And if you encounter it, you would hopefully not just get this feedback within the IDE, but you would also see within your project in SonarQube or Sonar Cloud, such a thing would result in a quality gate failure. When you have integration with your CI pipelines, as I have an example here for this project in GitHub, you can actually have the pipeline fail based on the quality gate failure, as I've shown in an example here. And I would also like to show that, of course, for those of you who are using commercial versions of Sonar, which would be necessary to find the vulnerability in the first place, you can also get nice feedback directly within your pull requests. So if you were interacting with a tool like Copilot, pasting stuff in from ChatGPT, you would get some really great feedback directly within your pull requests that you could also use to act upon.